following is a video review of the problem exercises for Chapter 7, Bonds and Their Valuation. Number one is a standard problem, right? We're calculating the present value of a bond. The par value is 1,000. That's standard throughout almost every bond valuation problem. The coupon is stated as $65, which is the same as 6.5% of par, or 1,000. The market rate is given as 8.2%. That's the required rate and the expected return on the bond. If we buy the bond today at its current market price, receive all the coupons, hold to maturity, we should receive 8.2%. 6.5% is the coupon rate, is less than the required return. This suggests, right, based on the relationship between those two rates, that the price will be below par. The price will be a discount bond. Okay, so as we put those values into our calculator, 8 in for N, years to maturity, 8.2 in for I per year, $65 in for payment, 1,000 in for future value, and calculate the present value, we get $903.04. This is an annual bond, so the N, the I per year, and the payment are all based on an annual bond. Additionally, this is at the end of the year. These payments happen at the end of the year, so your BGN or beginning of the year function should be off. The bond is a discount bond. It sells for less than 1,000. As I suggested, since the required yield, the 8.2, is greater than the coupon, right? The actual yield that this bond generates is greater than its coupon. I'm sorry, the actual required yield in this bond is greater than the coupon it pays. The bond sells at a discount. Okay, if that coupon was equal to the required yield, then it would sell at par, and if that coupon was greater than the required yield, then it would sell at a premium. We'll see an example of that next. Number two, Malco Enterprises currently sells a bond for $1,050, 6 years to maturity, annual coupon of $75, and a par value of 1,000. What is the current yield? The tricky part of this is just remembering the equation for a current yield. The current yield is equal to the current annual payment divided by today's price. According to the given information, the annual coupon is $75. Today's price is $1,050. We divide and we get 7.14%. So then another question that could be supplemental to this is the capital gains yield positive or negative? Okay. As you recall, the current yield plus the capital gains yield is equal to the yield to maturity, and we don't have a calculation for the yield to maturity here, but we should be able to look at this problem and figure out what is the capital gains yield. This bond is a premium bond, so as time moves on, the price or today's value of the bond will move towards its par value. So the capital gains yield will be a negative as today's price of $1,050 approaches 1,000. Every year, every time period, except for a change in the required yield, the price will move towards par. Number three, I can't pronounce the name of this corporation, Mordic. So Mordic Corporation bonds have 15-year maturity, 7.25 semi-annual coupon, and a par value of 1,000. Okay, so this is a semi-annual coupon. So every value that we put in, not every value, the values for N, the values for interest per year, the value for payment will all be affected by the semi-annual nature of this bond. The future value and the present value won't be affected. Okay, the going interest rate is 6.2%, and what is the bond's price? So it gives us a par value of 1,000, so that's our future value. It gives us a coupon rate of 7.25. 7.25% of 1,000 implies an annual coupon of $72.50. This also suggests a periodic coupon or semi-annual coupon. As you can see below, let me see if I can get my cursor going, 36.25. That's every 6 months. It says periods per year are two periods every 6 months. So the years are 15, so the total number of periods is 2 times 15 or 30. The yield to maturity on an annual basis is 6.2%, so we need to divide that by 2 as we do in this following step, RD divided by 2, and we get an interest rate of 3.1, which is what goes into the I per year function. Okay, and then we put all this information, we compute the present value, and here we have $1,101.58. This bond is a premium bond. Okay, in this case, the coupon rate is 7.25. and that's greater than the required return of 6.2. The bond pays through its coupon more than the required return of 6.2, so the bond sells at a premium. Number 4. McHugh's bonds currently sell for $1,025, pay a $90 annual coupon, 25 years to maturity. And we want to calculate the yield to maturity and the yield to call. Okay, so here we have two calculations. The one on the left is yield to maturity, the one on the right is yield to call. Basically, we just take information from the given problem, put it into the two problems, two calculations, and we solve for the two yields. There's a few differences. So the first difference is in the n. N on the left side is the yield to the years to maturity, and on the right side is the years to call, in this case 5. The price is unaffected. Today's market price is unaffected whether you call the bond or not. The payment is $90. That also is unaffected. That's driven by the bond contract. The future value is affected. On the left-hand side, the yield to maturity, we receive the par value at maturity. On the right-hand side, we're calling the bond, so we'll receive the call price of $1,050. That's the par value plus the call premium. Okay. Then the I per year is what we're calculating. When we do this calculation on the left, we get 6.88. On the right, it's 4.26, and then we take the difference, 2.62. This may show up later, or it shows up repeatedly. This is a kind of an interesting question. It requires you to calculate a yield to maturity and a yield to call and solve for the difference. So it's a good question to test whether you know both calculations. And then finally, number 5, roadside markets. They give you two mathematical solutions. I'd suggest you use the second. It's consistent with how we've solved every other problem, so I think it'll be most familiar. And again, this bond is a semi-annual bond. It says the coupon rate is 6.75%, which is $67.50 per year, or $33.75 every 6 months. So in your payment function, you'll put $33.75. The maturity is 10.5 years. That's a little bit unusual. We don't get many maturities that are in non-whole numbers. So you just, in this case, since it's a semi-annual bond, we multiply 10.5 by 2 to give us 21 periods, and that works out fine. The 10.5 really has no bearing or no complexity beyond that. The yield to maturity provided is 6.69. This is a semi-annual bond, so the semi-annual yield is 3.345%, and that's what we put in the I per year. The par is $1,000. It's equal to, the standard par value of a bond. And then we compute the price. The price in this case is $1,004.47. It's a slight premium bond, a little bit over $1,000. Also, you'll note the two rates. 6.75 was the coupon rate, and then 6.69 is the yield. Okay, since the coupon rate is slightly greater than the yield, right? The coupon that it's paying you, the bond is paying you, is slightly greater than that which is required. You're going to pay a slight premium for the bond. If you have any questions, please email me or post your question on the discussion. I hope this review of your problem exercises was helpful. Thanks. Bye.